new data on Earth-like planets. Since its launch in 2009, the Kepler Space Telescope has discovered lots of exoplanets orbiting distant stars. Some of them have an Earth-like mass, composition, and orbits. NASA plans to launch a new generation of telescopes in the 2040s. They'll help us find real twins of our planet and even get pictures of their surfaces. The return of Halley's Comet. It'll be another 41 years before we once again see the most famous comet in the sky. Halley's visits us every 75 years, so some will manage to see it twice in their lifetime. The longest solar eclipse. 166 years from now, I'll still be around then, the sun will go dark for 7 minutes and 29 seconds. This is pretty close to the predicted maximum. It'll also be the longest eclipse human civilization has ever witnessed in its 10,000 years. Arrival of the most notorious asteroid. 1950 DA was once the most probable candidate among near-Earth objects we know to actually strike the planet. Fortunately, the chance was later estimated to be not even 0.1%. It'll most likely pass by on March 16, 2880. Mark your calendars. And it'll become a solid evidence that we're safe for a while. The asteroid is more than a mile in diameter, enough to take out life on a planet. A new North Star? The Earth spins like a top. Watch one of these toys closely, and you'll see how its tip starts to draw circles in the air. The Earth's axis, an imaginary line going through the poles, goes full circle once every 26,000 years. It points at different stars along the way, thus changing the North Star. By the year 3000, the Gamma Cephei star will share this title with Polaris, as the Earth's axis will point right between them. The first near-Earth supernova. Antares is the 15th brightest star in the night skies. It's also an old red supergiant, 12 times larger than the Sun. Stars this massive age to a point where they collapse in on themselves, producing huge supernovas. For Antares, this will happen just 10,000 years from now, which is nothing for a 12-million-year-old star. The resulting burst will be too far away to affect life on this planet negatively, but the light show will be visible here on Earth even during the day. Message to the universe. Delivered. Arecibo is the encoded message describing humanity, life on Earth, and the advancement of our scientific knowledge. It was broadcast from the Arecibo radio telescope and aimed at the center of the M13 cluster, 25,000 light-years away from us. In 25,000 years, it'll finally reach its destination. A new closest star. About 36,000 years from now, the Ross 248 star will become our new closest neighbor. It'll be just 3 light-years away from us and overtake the title from Proxima Centauri, which is a bit more than 4 light-years away. Ross 248 will remain the nearest star for around 9,000 years and then move away once again. So, you didn't like the neighborhood or what? The first interstellar human-made object. In 40,000 years, Voyager 1 will reach a point within 1.5 light-years of the Gliese 445 star. It successfully reached interstellar space in 2013. But, unfortunately, it won't be able to power up any of its systems somewhere beyond the year 2025. Voyager 1 has a message too, a recording of greetings in 55 languages, music from classical to rock and roll, and sounds of the Earth's wildlife. A bare Saturn. 100,000 years from now, Saturn will lose its beautiful rings. It'll happen gradually over time as the planet's colossal gravity pulls rocks and ice from this belt floating around it. They'll all eventually fall and get crushed and burned by Saturn's atmosphere. Well, how rude. The ring system is in the middle of its life cycle, so we're incredibly lucky we got to see it in its full glory. The most frightening supernova. The WR-104 star will burst into a supernova in 3,000 years. This star is 75,000 light-years away from us, and the blast won't touch us at all. But there is a small chance it'll also produce a gamma-ray burst in the process. If this stream of energy happens to aim right at us, it will negatively affect life on Earth. Good news? Scientists say that's very unlikely. Colliding moons. The moons of Uranus are part of a highly unstable system. Some of them have orbits that cross paths. Uranus already has 2 rings of debris from past collisions of its natural satellites. Desdemona and Cressida will crash into each other in the next million years and produce new rings. A star too close for comfort. The rogue Gliese 710 star is approaching our solar system, and it will get just 1 light-year away in 1.3 million years. This won't have a major impact on the planets, but it could disturb the so-called Oort cloud, which surrounds our solar system and is full of comets. From Earth, the star will look like the brightest planets we see now, and we'll see many more comets in the skies. The closest star to ever go supernova. Within a few million years, the Spica star, which is only 240 light-years from us, will burst into a supernova. Supernovae are a problem for life when they're 3 times closer than that, but the supernova itself will shine in the Earth's skies as bright as a full moon. A time capsule for future generations. The Lagios 1 satellite was launched back in 1976 to gather information about the exact shape of the Earth and tectonic plate movement. But it also contained information about civilization on Earth at the time. It'll re-enter our atmosphere in 8.4 million years. If humanity is around then, they'll learn how life on Earth was in our time. Well, at least how it was some 40 years ago. Rings for Mars. Mars' moon, Phobos, orbits really close to the surface, and it continues to get 2 feet closer every century. 50 million years from now, it'll collide with Mars, resulting in a massive amount of debris going into orbit and forming a ring system around the red planet. Oh, can't wait for that. Days on Earth will get longer. No, really? 1.4 billion years ago, the Moon was much closer to our planet. It made the Earth rotate faster, so the day was only 18 hours. The Moon is continuously moving away from Earth. In 180 million years, we'll gain 1 extra hour. In a little over 2 billion years, a day on Earth will be 36 hours long. No more solar eclipses. 600 million years into the future, the Moon will move away from the Earth too far to cover the Sun during eclipses. Those will become ancient relics. The Sun will get too bright. It'll take about 1 billion years for the Sun to raise its luminosity by 10%. This will be devastating for planets in the solar system, and life on Earth won't be possible beyond this point. By then, our species will likely have found a new planetary home. The Sun will swallow the inner planets. In 5 billion years, the Sun will begin to evolve into a red giant, growing hundreds of times its current size. It'll swell up so much, it will eventually engulf Mercury, Venus, and possibly Earth. The new Goldilocks habitable zone may shift to the orbits of Jupiter and Saturn. This process will take a bit under 3 billion years until the Sun reaches its maximum size. After that, our star will shrink into a white dwarf. The most epic event ever. Around the same time our Sun is swelled up, the nearest neighboring galaxy, Andromeda, will come too close to the Milky Way. If we could watch our galactic neighbor at this time, it'll get larger and larger as it approaches. Then, the 2 galaxies will start to merge. Bright blue stars will burst into life. New constellations will form. The 2 spiral galaxies will now be a single giant elliptical one. Wow, I've set an alarm on my smartphone so I don't miss it.
Do me a favor, will ya? Try to imagine the first time you went camping. Maybe you went with your parents. Maybe it happened on a class field trip with your schoolmates. Regardless, try to picture, or remember, what it felt like as the day was coming to an end. The sun has set, but there's still some light outside. Let's say you were lying down, trying to rest for a bit. What's the first thing you remember seeing when looking up? If you're anything like me, it was probably the overwhelming number of stars twinkling right before you. These stars, most of which you can see without any fancy devices, are part of the Milky Way. Believe it or not, our amazing galaxy is almost as old as the universe itself. Age aside, it's also a pretty nice place to be. The Milky Way is like a cosmic nursery where new stars are born. And let me tell you, it's home to some of the most fascinating places, at least from what we can see in pictures. Take the Mystic Mountain, an area in the Carina Nebula. Here, things are always splashing and full of energy. That's because of gas columns collapsing and creating crazy opposing jets that are thrown around like acrobats in a circus. It's like a signature move for stars being born, you know? And if you take a look at this awesome picture, you'll see the elements putting on a colorful show. Blue represents oxygen, green is for hydrogen and nitrogen, and red is the sizzling sulfur. Ready for our next stop on our ride through the Milky Way? Check out these huge, twisted clouds of interstellar dust and gas hanging out in the center of M16, also known as the Eagle Nebula. We've got ourselves the super cool Pillars of Creation, which are like towering columns where brand new stars like to hide and chill. Now, I know this ain't the first time the Hubble telescopes captured this epic sight, but trust me, this is the most mind-blowingly detailed image yet. The pillars are getting showered with crazy hot ultraviolet light from a bunch of young stars hanging just outside the frame. These stellar superstars are actually causing the towers of dust and gas to gradually get worn away by their gusty winds. Brace yourself for the numbers, too. These pillars of creation stretch out for about 4 to 5 light years. Yeah, it sounds big, but in the grand scheme of things, they're kind of like the cute little siblings of the larger Eagle Nebula, which spans a whopping 70 by 55 light years. The nebula was first spotted back in 1745 by an awesome Swiss astronomer, and it's about 7,000 light years away from our humble abode, in the constellation Serpens. Here's the quirky part though. As productive as it might sound, the Milky Way's star-forming activity is quite rare when compared to other galaxies. Astronomers have noticed that the pace at which stars are being born is actually dropping, and they're itching to figure out why. But before we can dive into this weird phenomenon, let's look at how stars come into existence in the first place. It's hard for us to know for sure from down here. What we can gather about a star's life cycle comes from looking at those within our local Milky Way. Stars are formed in colder clouds of gas and dust called nebulae. These areas are pretty common throughout most galaxies. These nebulae have low temperatures that are crucial for hydrogen gas to stick together. As the clump gathers more gas, it causes movement, which itself creates energy. When more gas collides with the already formed clump, all that energy transforms into heat. This keeps going until the temperature grows considerably, sparking the birth of a star. The most secure time of a star's life is also known as its main sequence. I'll spare you the chemistry lesson, but during this time, the star produces both heat and radiation. It's because of the radiation that there's pressure around a star, and it's also the reason for most of the light found in a certain galaxy. Now let's talk star sizes. The bigger the star, the faster it consumes its fuel. These massive stars shine the brightest, emitting high-energy UV light. On the other hand, lower mass brighties live longer, despite not being as shiny as their larger siblings. There's a variety of star sizes in most galaxies we're able to see from down here. Some stars are 0.1% the size of the Sun, while others have 10 times its mass. Once a star finishes up its fuel, it welcomes its grand finale and transforms into a faded star. Stars about the same size as the Sun or smaller can no longer produce radiation at this stage. Gravity takes over, causing their matter to settle into a white dwarf. For bigger stars, the timeline changes a bit. They too collapse, but there's a lot more stuff burning, and it's also hotter in there. This collapse creates a stronger core. When all of the star's insides are done for, the outer layers collapse in a jiffy. It bounces off the core at nearly the speed of light. It's an impressive, explosive event called a supernova. The blown-out material becomes the basis for future stars. It also leaves behind a black hole. Now that we know a bit about a star's life, let's try to look at each generation, if you'd like. Stars don't just pop up constantly at the same rate. Currently, the universe is manufacturing only about 1/9 the number of stars compared to its star-forming glory days, which happened roughly 10 billion years ago. One study gave us a peek on the history of star forming. In writing it, 2 scientists teamed up to gather a ton of data about galaxies. They sorted these galaxies based on how far away they were. By doing this, they could track how the brightness of galaxies has changed over the universe's lifetime. Since stars give off most of a galaxy's light, they could use that brightness to figure out how many stars were forming, using some fancy math. Their findings confirmed that star formation was pretty wimpy when the universe was young. But as gas started to gather in galaxies, boom! Star formation skyrocketed until about 10 to 11 billion years ago, when it hit its peak. After that, star formation took a nosedive. In today's observable universe, it's dropped a lot. That means around 50% of the stars we see today were born in the first 5 billion years post-Big Bang. A mere quarter formed in the last 6 billion years. So what's causing this cosmic shift? Well, scientists think it's all about that cold gas that stars need when they're born. When galaxies form, the gas gets concentrated inside, leading to a star formation extravaganza. But then, the gas is used up quickly as stars doze off. When supernovae come into play, they blast away that much-needed gas for future star making. Not to mention, it also changes the chemistry of that gas. This crucial piece of information could be a starting point for the star-making decline we see today. Scientists are still not sure why this gas becomes useless. Galaxies are also pretty complex to begin with. There are all sorts of forces involved in maintaining their balance. For instance, when a supernova goes boom, the shock waves can sometimes cause turbulence and clumping of the gas, sparking the birth of new stars. But if the supernova is too wild, it can blast that same gas right out of the galaxy. With no gas left in the area, there's little to no chance a new star could form. Now, what does the future hold? Some scientists can't help but wonder what might happen if no new stars pop up. The universe might be simply filled with black holes and fading stars. Solar systems would become inhospitable as their stars lose power, and those ravenous black holes might munch on whatever material is left. As gloomy as it seems, you do have to admit it's a mind-boggling concept. Luckily, we don't have to worry about it happening anytime soon. The universe is a whopping 13.7 billion years old, but the dark era isn't expected to kick in until somewhere way further in the future. But hey, this is just one possible outcome of the decline in star formation. Who knows what other wacky possibilities the universe holds?
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between two colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them, but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of hundred years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller, but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there.
You're in your Galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action. from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The Star Wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the Star Wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of, currently. Who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the Star Wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there?
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b, and astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there, and if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the Planetary Nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its two host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light-years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a spacebody is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13th, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.